So for number 1, you would calculate the line of best fit, either in your calculator or on Desmos, however you wanted to do that. I'm going to give you the answer for that, but if anyone needs to see that in Desmos or the calculator, then we can do that. I don't have a lot of decimals, yeah. So y equals 0.89, you could put that, you could put more decimals, you could have, I'd say leave at least 2 decimals, but the decimal will tell you what to round to if it's a type in, fill in question. And then number 2, I'll show you the answer with that as well, and then if we want to see how that would be done in Desmos, so the calculator would do that. But using the equation you found, you either algebraically had to put 7 in for x and solve for y. In the calculator, you could have stored 7 or looked at your table and found your y value. Same thing in Desmos. Do we need to see how this is done in the calculator or in Desmos? Which one's Desmos? Putting it in. Okay. So putting this in, I would add a table. So hit the plus, add a table, and start putting in my values. So 1, 1, 2, 1.5. Once Desmos figures out your pattern, you can fill in the rest of your table by hitting enter. 3, 2.2, 4, 3.8, 4.7, and 6. If you need to, I don't know if this will be available on the SWO, but hit the plus so you can see where your line is. You have to know the equation to put in, so your y1 tilde mx1 plus b. So it has to look like a line or the equation of a line, but with the y1, x1, and the tilde, the squiggly line. And you would get your m and your b. So that would help you write the equation for number 1. And again, it would tell you how many decimals to round to. If it said round to 1, this would be 0.9 and negative 0.1. If it said round to 2, 0.89 and negative 0.09. Or it may say round to the nearest integer, which would be 1 and 0. Say again. I'm about to shut up. So in the next line, I would need to type in this equation. I'm going to just use all the decimals. Y equals 0.89, 1429, x minus 0.08, and then put as many 6s as you can. Because it's a repeating 6, it is rounded off to 7. And go into your gear wheel, make that table, and then add 7 to that table. I think when I did it, I may have not used as many 6s that I did. So 6.15, or about 6.2 if we're rounding to 1 decimal place, would have been our answer there. Anyone need to see that in the calculator? Yes. Let us open this. In your calculator, you would go into Stat, go into Edit, fill in your L1 and L2. And then once you have all of your data points in there, you would go back into Stat, scroll over to Calculate, and go down or hit number 4. And then in this case, because number 2 is asking about using this, I'm going to store this. So go down to Store, hit Alpha, hit Trace, and store it in one of these by hitting Enter. And then either hit Enter twice or go down to Calculate and hit Enter. It'll give you those same decimals, so you would use those decimals to write your equation for number 1. Then to get your answer, you could go to your main screen, so second mode, store 7 in your calculator, so 7, STOX, and then hit Enter. And now that 7 is stored in for X, I could go back and grab my equation that I stored, so alpha trace, and I stored it in 1, Y1, and I hit Enter. And now this equation that was stored has my 7 in for X, and it would give me that answer. Other questions on line of best fit for calculator or desmos things? I'm just going to show you. For number 3, you had to know what was missing, what we didn't know, and that was the number of hours. So we could say that sum x, we're going to multiply the number of hours by the 15, since it's 15 per hour. So it'd be 15 times x. It tells us we're adding a 1 times b is 60, so 15x plus 60. And we know the final bill or the total is 195, so that would be our equation, and then we can start to solve. And as we solve, we get 9 hours. Questions on that? Anyone still need this? For number 4, the easiest way we could have done this is 1, solve this so that it's in slope-intercept form. So what would we do to solve this? Subtract x on both sides. We have negative 2y equals negative x plus 14, and then divide everything by negative 2. We have y equals positive 1/2 x minus 7. It would start at negative 4, 0, 1, 2, 4. And if it's parallel, what do we know the slope is going to be? 1/2. So from this point, I can go up 1 to the right 2, up 1 to the right 2 until I hit my y-axis at 2. So my equation would be y equals 1/2 x plus 2. And then for number 5, if we're solving this equation now for x, what would we do first? Subtract y. So 3x equals negative 5y plus 10. And then divide everything by 3. So I'm going to show you this because there are different ways to answer this problem. So if you divided it separately, you'd have 2 fractions. If you divided it all together, you'd have 1 combined fraction. You could also divide it all together and then see that these both, your numerator and numbers, share a negative 5 and factor that out. Or write write it so that the fraction is in front. All of these are the same answer, just written 4 different ways. Questions on the shark bite? So now we're going to go over the SOL standards, starting with A7E. So with these A7E, there were 2 different ways you could have done this. One, algebraically, put in -3 into x, find your y. Put 6 into x, find your y, and you would get those 2 answers. If you use desmos or your calculator, you can put this in, look at your table where x is -3 and 6 are, or put those in and find your y values. Anyone need to see that one done in desmos? 9x squared plus 1. Okay, so I have my equation, I go into my gear wheel, I make this a table, and I'm looking for -3 and +6. And I would just put in those 2 answers. For SOL 8.8, this is all your direct and inverse variation. So a lot of this you have to know, but you could check in desmos. So for number 1, it tells us that this varies inversely. So anything direct is now eliminated. We can eliminate that. Without even really reading this, I can eliminate A and B because either way, those aren't direct or inverse variation equations because those are adding, and we don't add in direct or inverse variation equations. So then it has to be B or D, and we have to know which one looks more like an inverse variation equation. So up at the top, they're using variables D and W. So I'm going to talk through this, how you would do this without the calculator, and then talk about how you would do it in desmos also. So even though they're using different variables, that would still be like your y and x. Whatever comes first would still be like your y. Whatever comes second would still be like your x. So this would be D equals K over W, or K equals D times W. And the equation that looks the most like one of these is B. They just actually found what the K value is by multiplying the 2 numbers, 2 and 50. Now, what you could also do is, if you eliminate these, you could graph these 2 and see, because we know it says varies inversely, which one makes a curve. This is the only one that would do that. So if you know that inversely curves, then that would also help you find that answer. Then for this question, it's asking how many days would it take 60 workers. So using either B or this original equation, you could put those numbers in and find your answer for D, which would be about 1.6 repeating days, or about 2 days. Questions on number 1? Number 2 now says directly proportional, so that would be a direct inverse. So again, we could eliminate A and C because these 2 are adding and direct and inverse don't add. However, B and D both represent a direct inverse, so we have to know which one is the right one. So as we're looking at the variables given, if C is like our Y, and that has to come first, C has to be equal to whatever. So it couldn't be B. If you also wanted to know which number is correct, you could put the numbers in. So our equation would be C equals KB, which is that same format. We could put in 180 and 2 and figure out our K value, which was 90. So if you use desmos for this, it would give you 2 lines that both go through 0. So that wouldn't really help you determine which one is which. You'd have to know that C is like your Y and that comes first, so that would have to be your answer. Questions on that one? For 3, there are a couple different ways you could do this. One, you could graph each of the ordered pairs and see which one makes a line that goes through 0, 0. You could also start dividing each set of ordered pairs. Since this is a direct, it has to be y over x, and see which ones match. So if I start with this one and I divide -2 over -5, I get +2 over 5. So I'm looking for what would match that. 2 over 5 would match that, and -4 over -10 would also match that. Do you have any questions on that one? On the next page, number 4 is asking which of these equations represent a direct variation. So you have to know that it has to be a line, it has to go through 0, 0. So if it is squared, or something that is not a line, that's automatically out. So x squared would be out. If we're dividing x, that would be an inverse, so that would be out. This is in the format to find k for inverse, so that would be out. This is a line, but it doesn't go through 0, so that would also be out. You could also graph each of these and see which of these are lines that go through 0. And that would help. But since those 3 were answers. Number 5 asks about graphs. So if you know that it's a line that goes through 0, 0, the only one that does that is this one. This one is a line, but it doesn't go through 0, 0. So only this one is our answer. 6 is the same thing. Only this one would be our answer. Because even though this is a line, it doesn't go through 0, 0. For 7, you have to find 3 points that would be a direct variation. So again, you could put all of these into desmos, see which ones form a line, and go through 0, 0. You could also do it algebraically by dividing y over x and seeing which of these are the same. The only 3 that were the same were the middle 3. Middle-ish 3. There's like 7 or 8 of them. Questions on that one? This is kind of part B, and I just copied the same order pairs on the next page. So now it's asking for which one would create an inverse, and with inverse we have to multiply. So if we multiply them all together and see which ones are the same, only 3 of them would work. You could also put these, so if you had already graphed these points, some of them will make a line and some of them will curve, and the curved ones would be your inverse. So let's see, I think it was these 3 would have made a line, these 3 would have curved, these 2 I guess would have just been out somewhere else. And then 8 was similar, find a direct variation. So if you divide, there were 3 that were the same, or you could graph each point and see which ones make a line that go through 0, 0. For number 9 is asking you to plot 2 other points that would represent a direct variation. Anytime you get this one, 0, 0 should always be one of your points because that's the easier one to find. And then you can find your slope and plot any other point. I plotted them all, so you could plot any of those two, and it would be right. Questions on that one? To check yourself in Desmos for this, you would have to know your k value or your slope, put in your equation, and see if all your points fall on your line. 10 is similar, but they gave you a different point. If you started at 0, 0 and you counted your slope, you would get negative 3 over 3, so negative 1. So there would be many possibilities in this. You just have to have 3 of those points. So don't draw them all, but pick 3. For, it says 11 and then it jumps to 12 and it didn't really ask a question, but I put that same table on the next page. So for this, it's asking which is true about this relationship. So there are a couple different ways you could do this. Algebraically, you could determine is this direct or is this inverse by multiplying and seeing if they're the same, or dividing and seeing if they're the same. In this case, multiplication works. You would have to know that since you're multiplying, that's inverse. So anything that's direct would be eliminated. And then you would have to know which type of equation looks more like an inverse, and that's the one where we're dividing by x.
We're just curious about
Okay. Graphically, they give you two equations. They're just split between direct and inverse. If you graph both of these, one's going to give you a line, one's going to give you a curve. If you plot these points and see which one matches, these curve to this equation. So if you did it like that, you would have to know whether it's direct or inverse. Questions on that one? Then we get into the last one, SOL A9, which is all about line/curve of best fit. So I have all of these up here in Desmos, and I will show you very briefly how I got the answers. But for number one, put these in your table, and it's asking which best represents this equation. When I put these in, it curved, so that means A and B could be eliminated because those were lines. So it has to be C or D. The one with the most decimals is usually your answer, but just to double check. So as we put this in, I eliminated A and B. I should probably just the one that matched these points the most was the purple line. It went over top of the green points. So that would be my answer. Do you have any questions on that one? Sometimes when you find the curve of best fit or the line of best fit, it's not always the one they give you. So you may be looking for one that's close to or similar to. If you did like the y1 tilde, all of that stuff. For number two, you're going to do the same thing, but this one tells you it's using the line of best fit. So you would only use line, not quadratic. So as I put in all my points and I put in and I find my line of best fit, it gives me those values. Then the second part of that asks to find the y value when the input was 5. So you could put in your new equation, go into the gear wheel, make it a table, put in 5, and see what that value would be. Because I used all of the decimals, I got 10.619. They probably rounded it. And as you see, the number I got is not up here, but the closest one to it is B. And sometimes that will happen. If you use more decimals than they use, as long as you find the one that's close, you're good. Number 3 says determine the quadratic curve of best fit. So you know you're looking for the one that looks like a curve. So as you put those in, you would see that it curves. You would have to remember that this should look like the quadratic. So your y, whatever, mine says 3 because this is my third table. Yours would say 1 because you would probably only have one table. But y1 tilde ax1 squared plus bx1 plus c. And then you could find your ABC values. After you find your ABC values, you can do the same thing. Put those in your equation, quadratic equation format. Make it a table. And you're looking for when x is -4, what is your y value? So about 2.33, 2.3. It would say what to round to. Before we move on to the next page, do you have any questions on any of those? Number 4 is another problem where we're doing quadratic curve and we have to find y value when x is something. So you would put in all your data. Put in all your data and you would get these values. 3, 2, -8. You could write that equation down and then write it in a new line, make a table, put in your x value of 8, and you would get your y value of 200. You could also do it algebraically, since the numbers are nice. Either way. Number 5, you could do without a calculator if you know this. This makes a U, so it can't be linear. It can't be A or B. It has to be C or D. These are the same equations, except one is positive, one is negative. It's upside down, so it has to be negative. So D would be our answer for that one. Six gives us a table, and in all of these words, it does say use the quadratic curve of best fit. So it'll either tell you, or you could graph it and look at what it looks like. So when you put that data in, you would get this equation, 2x squared plus 77x plus 50. And then it's asking you to find when x is 13, so you could do it algebraically or do it in desmos. I'll show that real fast. And you would get your y value of 1389. I think this one is 6. But that's 13, you get this. And in this, when you like zoom in, it kind of looks linear, but it's curve. It's just really big. And then I think there's just one last one. This one, anytime you have years is automatically going to be line of best fit linear because years happen in a linear fashion. We don't skip years. But you also have to remember that anytime we have years, we're going to change whatever the first year is to 0. And every year after that is going to be how many years has it been since the first year. So 2000 is really easy because you start at 0 and then it's whatever the number says. But if it said 2022, 2024, and it was skipping by 2s, 2022 would still be 0, and then 2024 would be 2, and whatever else. So make sure you change that, otherwise your equation becomes way bigger than you really want it. Then when you find your line of best fit, so this was the answer, and I'll show that in decimals here in a second. You don't need all of those decimals, but if you run to like 2, it'd be 2.1 plus 433.92. And we're looking for the best prediction of average farm use. I don't think that's what this is, size in 2014. So when you change these to how many years has it been since, you would put in 14, not 2014, because 2014 would be 2014 years after the first year, and that's not what we want. So if you put in 14, it would give you 463 and some decimals, but D would be your final answer. So those would be all of our values. Here would be our line of best fit. You would put that in a table, put 14 in, and you would get your answer. Do we have any questions on anything on this? By now we've gone through everything that some of the stuff I was like, well, just wait, we'll go over that. You should be able to go back and try some of those ones that maybe you just wrote down the answer but didn't really understand. And you should have time later to do that. Before we continue in this packet, I'm going to go through this academy question real fast. And rewrote it because it's really small. Okay, so this says A times T plus Z in parentheses equals 45Z plus 67. So if you have not done this Khan Academy yet, write this down somewhere so that we can know how to do it for later. We are looking for Z. We're trying to solve this for Z. There's a Z on this side and this side. We need to get them on the same side. This one is in parentheses. To get it out of parentheses, we're going to have to distribute. And that kind of doesn't make sense, but it will here in a second. So distribute first. So we have AT plus AZ equals 45Z plus 67. Then you're going to move all the Z's to the same side and anything that doesn't have a Z to the opposite side. So it doesn't matter how you do this, but let's say I want to move 45Z over. There are different ways to do this. I was trying to figure out what would be the easiest. Sure. So I'm going to move 45Z over, and I'm going to get rid of AT. Do this all at the same time. So here my ATs would cancel, my 45Zs would cancel. I have AZ minus 45Z equals 67 minus 18. Now, because these both have a Z in them, I could factor out a Z. That would be like my GCF of these two. And if I factor out a Z, what's left is A minus 45 How would I get z by itself now? Divide everything by this set of parentheses, or this a minus 45. So c would equal 67 minus at over a minus 45, which is this first thing. So there are different variations of this depending on how you start. You could have moved whatever first. So you'll either be given something that looks like this, where you have to distribute and then move and then just divide, or it'll already be like this and you have to move it and then divide. Do we have any questions on the Khan Academy? Five, 13, 9, 19. Right. We are going to continue working in the SOL bracket now. Make sure you have that out. So the last page we didn't get to this page, but I'm going to pull this up. You can start writing this down. I don't know if these have page numbers or not. But for the A4AB, properties of equality, and start writing these down. And I'll read them off and go back up. Commutative property of addition is the change of order of addition. Commutative property of multiplication is that same thing, change order of multiplication. Associative property of addition is the change grouping of addition. And then with multiplication, same thing, change grouping of multiplication. Additive identity is where you add 0. Multiplicative identity is where you multiply by 1. Additive inverse is where you add the opposite. So if you have 3, you subtract 3, or if you have negative 3, you add 3. Multiplicative inverse is where you multiply by the reciprocal. Distributive property, multiply distributes across addition or subtraction. Subtraction property of, I skipped one. Addition property of equality, add the same to both sides, add whatever to both sides. I'll scroll back up in a moment. Multiplication property of equality, multiply the same to both sides. Division, the same, divide the same on both sides. Substitution property of equality is simplify or combine like terms. Reflexive property is equal to itself. A equals A, 3 equals 3. Symmetric property is when you switch the sides of the equal sign. A equals 3, 3 equals A. Transitive property of equality, if A equals B and B equals C, then A equals C. I'm going to. For these, there aren't any desmos tricks. This is something you have to know what these are. In a moment, I'm going to scroll back up. Anyone need anything higher than this? Remember, you don't need to write these word for word. If you know kind of what it's supposed to do, you could write it or simplify it, summarize it, whatever. Yes. For any of 10 through 15, it's based on the chart on the side. Do we have questions on any of those? Remember that this is also on Canvas, so if you didn't get some of these, I am going to move forward with the next page. For literal equations, this is what we just talked about. So when there is more than one letter, you must solve by hand. Literal equation doesn't have a desmos hat for it. For 16 or 17, would we want to see either one of those? For your systems of equations, the easiest way to do this in Desmos is to graph the two equations, look for a point of intersection. If they intersect, you have one solution, you write that as ordered pair unless it's just looking for an x or y value. If you graph the two lines are parallel, you have no solutions. If you graph and the lines are stacked or one on top of the other, that's infinitely many. So whenever it says systems of equations or you're given two equations, that's a system and you can graph them and find your solution. For 18 through 20, do we need to see or want to see any of those in desmos? For the bottom section, A4E, those are all word problems. 2 of them are just word problems. 2 of them are systems word problems. Do we want to go over or see any of those, 21 through 24? Aubrey?
24.
24. Or 2?
Yeah.
22. So for 22, Rosalind sold half of her coin collection and then she bought 10 more. She now has 45. How many did she have to begin with? So half of whatever she originally had, how many she had to begin with would be our variable. And she sold half of that, so that'd be 1/2 x. And then she added 10 to it. And now she has 45. So you have to be able to look at those, find the important pieces of information, put all of that information together using your operations. Half would be multiplying, 10 more, and be adding. Now has your total would be 45. And then you could do one of 2 things. Solve this algebraically or put this in desmos. Aubrey, which would you prefer?
Can we do it algebraically?
Sure. So algebraically is subtract 10. We have 35. And then get rid of the 1/2 by taking the reciprocal, multiplying by 2 on both sides. How many coins did she have originally? 70. And remember, again, with equations, you could just type this in and it would give you x equals 70. You may have to zoom out though on desmos. Any others? 21, 23, or 24?
Systems.
Yeah, 23 or 24. So for 24, Oscar bought 4 puzzles and 6 video games for 128. This should tell you that this is probably going to be a system because it has a bunch of numbers. Devin bought 3 puzzles and 2 video games for $54.74. Find the cost of each. I'm going to use desmos for this one. So I'm going to say my puzzles are my x, my video games are my y. So our 2 equations, we have 4x plus 6y equals 128 for Oscar. And 3x plus 2y equals 54.75 for Devin. And then I'm going to put both of those equations into desmos and see where they intersect. For word problems, you shouldn't get no solution or infinitely many because that wouldn't make sense. But if it's just a systems problem, then you could. 4, 6, 8. What was the other one? So these are big numbers, so you may have to zoom out. Find where they intersect. It gives us an x and a y. It did say the cost of each, so we could say our x, which was our puzzles, cost $7.25 a piece, and video games, which was our Y, cost $16.5 a piece. $7.25. If it said just find one, then you would only find one. Aubrey, thanks, North.
How would we do it on people?
You would need to either solve using elimination or substitution. This one would probably be better with elimination, so I'll show that here in a second. Yeah. So I say, if you do this algebraically, the chance that you make mistakes could go up. So if you get systems, I would rather you just graph it. But if you did do this algebraically, you have to decide, are we eliminating x or y first? Let's say we're eliminating x. These would need to, actually I can change it to y. These would need to be the same, so I would need to multiply, not this one, the other one. This all by 3. I have 4x plus 6y equals 128. And 9x plus 6y equals whatever that is. Someone multiply 3 and 5475 together. Okay. And then to eliminate these, since they both are plus, we would subtract. Our y's would cancel, and we're left with negative 5x equals whatever this is. Someone subtract this one together. And then divide with word problems. If you're solving it algebraically, you should not get negatives. And what would that be? So 1.2. So then you would have to take that x value and put it back into one of your equations to find your y value. So we could multiply what is 725 times 4? 29. And then subtract. And then divide. And I'm assuming that's 16.5. So again, a lot more work if you're doing it algebraically, which you could do, but be careful when you're doing it because in the heat of the moment you may make mistakes. So double check it in Desmos if you're doing it algebraically. On say that again. What did you say? Okay, so for solving inequalities, this is similar to solving equations. Type the inequality using lowercase x's. The solution will be the shaded region. Solutions can be on solid lines, but not dotted lines. And then it shows you which one is which. So this is less than, and you can write it one of two ways, using your inequality notation or your interval notation. So less than would be x is less than whatever number, or negative infinity to that number, both in parentheses. Greater than would be x is greater than that number, or that number to infinity, both in parentheses. Less than or equal to would be x is less than or equal to that number, or negative infinity to that number with a square bracket. And then greater than or equal to would be x is greater than or equal to that number, or that number with a square bracket to infinity. So for the problems given below, notice that they have an inequality notation, an interval notation, and they have a graph. They want you to do all three. Remember that less than or equal to, greater than or equal to would be a closed circle. I don't think it said that already. And less than, greater than would be an open circle. On this page, do we want to see any of the 1 through 4 in Desmos? Who's still writing this down? Okay. To the top part. On this next page, it's going to look very similar to the one we just did not too long ago. The wording is basically the same, except for the very last one. So I'm just going to skip down to that one. Does anyone still need this? So these are all the same as before. The only difference is this last one says is if A is less than B, and I'm trying to make this bigger, but it's not. If A is less than B and B is less than C, then A is less than C. So if you want to go back and write all of those in, you are more than welcome to, but I'm not going to go through and read them all again. Just as before, they have another inequality that they solved, and 5 through 10 has, between this step and this step, what do they do? Do we need to see any of those? Yes. Then I'm going to go on to the next page. Linear inequalities. For less than, we have dotted line shaded below, greater than dotted line shaded above, greater than or equal to solid line shaded below, less than or equal to solid line shaded above. I said that backwards. Wrong. These are backwards. solutions are in the shaded region or on a solid line. For number 11 or 12, does anyone need to see either or graphed or the answer in decimals? Now, some of these problems will ask you to graph on the SL, but you will be able to like click the area that needs to be shaded or draw the line. It'll have specific directions on that. Anyone still need those? For the bottom section, the inequality word problem, so that's, you have to set up the word problem and then be able to solve it or put it in desmos. Do we want to see any of those 13 through 15? Right, on the next page, we are dealing with systems of inequalities. And the solutions are in the overlapping shaded region. Would we like to see any of 16 through 19 in desmos? Did you have one?
Sure.
Which one? 16. As soon as everyone's finished, I'll do 16. So for 16, it says graph the following system of inequalities. So I could put these in exactly as is, x plus y is greater than -2. And it will graph that, shade it for me. And then the next one, do the same thing, x minus y. Okay. Is greater than 3. And if you had a question like this, it would probably ask which is the overlapping shaded area, and you would choose this section. If you actually had to graph it, which you may or may not, you would somehow be able to plot points, make a line, make sure it's dotted, and then show the shaded area. Any others on this page? Now, if you actually had to graph it, you could count your slope and find your y-intercept, and you may need to zoom in to do that in order to actually graph it. On the next page, this is all about slope. So we have positive slope, and you can just draw a positive line, negative, 0, and undefined. To find the slope of a line, pick 2 points and use rise over run. So it's telling you count your slope on the line. Do we want to find the slope of any of the ones drawn, number 1 through 4? And then there's one more thing that I need to show you on this page. Down below where the desmos picture is, if you open the graph settings and turn off the minor grid lines and change both of the steps to 1, then that may make it easier for you to count the rise over run, or you could just zoom in, either or. So that's really if you don't want to zoom in or if you're not able to zoom in. This is also for if you're putting in 2 points, so like for numbers 5 through 8, and you want to count the slope a little easier. Maybe they're too separated and there's a lot of grid lines and it's throwing you off. This could also help. Anyone want to see this done in Desmos? Anyone still writing this down? On the next page. This one is about writing linear equations, so you have to know your slope-intercept form. Y equals mx plus b, where m is the slope, b is the y-intercept. Y and x are usually your ordered pair. If you have a multiple choice question, type in the answer choices to see which matches the given information. For 9, 10, and 11, you would have to write it from the graph, so you'd have to know how to find your slope, how to find your y-intercept. Do we need to see any of those? And then the other 2 ways to write equations. If you're given a slope and a point, you're going to graph the point, type in y equals mx plus b into desmos, add sliders for m and b, change the m slider to your given slope, change the b slider until it goes through the point. If you're given 2 points, graph the 2 points, type y equals mx plus b into desmos, add the sliders for m and b, change both sliders until the line goes through both points. So 12 and 14 are an example of given a slope and a point, and 13 and 15 are examples of given 2 points. Naima, do you not have this? Did you want another one? Or this will be our last page, but do you want to see any of the questions in Desmos? As you're finishing writing this down, I'm going to say a couple things. One, we only see each other one more time before you guys take your SOL, so we are going to finish this, and then you'll be given one more SOL packet just as the last. Here's some additional practice problems, but that will be more you guys working amongst each other than me up here. On the 18th. And then if you have not been working through any of these problems, trying them in Desmos, trying them on your own, make sure that you are doing this. The only way you will know all of these things and steps and be able to do them on the SOL is if you practice. You will not be given help or anything if you forget on your SOL. And then remember that you have 4 Khan Academies due today. 3 on direct variation and 1 on literal equations.